Let's go ahead and talk about giving some meaning to numbers or putting numbers into perspective. As with problem solving, there's no one way to do it, but we can look at a few techniques to help you out. Let's look at estimation, comparison, and scaling. How high is 1,000 feet? So, of course, 1,000 feet is 1,000 feet high, but for most people, you can't just visualize what 1,000 feet is. But what if we thought about it as every story in a building is about 10 feet from floor to ceiling? So 1,000 feet is about a 100-story building. So that makes a little more sense. Of course, that doesn't mean that we're all going to visualize the exact same 100-story building, but it does give a little bit more meaning to the idea of 1,000 feet. So the 105-story World Trade Center has a roof height of 1,368 feet. So it has about 13 feet per story. So our estimate was off by about 30% for the World Trade Center, but it's still reasonable for us to think about a 100-story building when we think about 1,000 feet. So estimations are useful even if they're not exact, and they give us a broad range of the exact value. For example, you can infer a lot about the chances of a town or city simply by knowing whether its population is 10,000s or in the millions, because the former is the size of a modest college town where the latter is a huge city. So estimates that only give a broad range of values, like in the millions, are called order of magnitude estimates. In ordinary language, we usually indicate an order of magnitude estimate by actually using the word order. So you might even say the population of the United States is on the order of 300 million, even though it is possible to look up a more precise value. It was 331 million in the 2020 census. So the order of the 300 million means the population is closer to 300 million than to say 100 million or 500 million. When astronomers say the number of stars in the galaxy is of order 100 billion, it could be anywhere within a factor of 10, between 10 billion and 1 trillion. It's a much wider range than the range when we talk about on the order of 300 million, but it's appropriate because the numbers are so much larger that we can have a larger range. Example 8 is the total annual ice cream spending in the United States measured in thousands of dollars, millions of dollars, or billions of dollars. So let's calculate the total annual ice cream spending by multiplying the amount the average person spends per year by the total population. So let's guess that the average person has 50 servings of ice cream per year at a cost of $1 per serving, and we've got about 300 million people. So 50 servings times $1 per serving gives us $50 per person. Now we've got to figure out how to multiply that by 300 million. Well, let's write out 300 million to figure out what it would be in scientific notation. So I move the decimal 8 times. So I've got 3 times 10 to the 8th is 300 million. I want to multiply that by $50 per person. Well, let's go ahead and also put 50 in scientific notation. That would just be 5 times 10 to the first power. So 5 times 10 to the first power times 3 times 10 to the 8th power would give us 5 times 3 is 15 times 10 10 to the first times 10 to the 8th. We're going to add those numbers. So 8 plus 1 is 9. Well, we had 10 to the 8th up here in millions. If we add, it was 300 million. If we add another digit, because we were at 300 million, so we were maxed out on the millions, now adding another digit gets us to trillions. I'm sorry, billions. So we are at billions, 15 billion would be our estimate of how much people are spending, how much the annual ice cream spending in the United States is. So you're probably familiar with common ways of expressing scales used on maps. A scale can be something like 1 centimeter represents 1 kilometer, or written more simply, 1 centimeter equals 1 kilometer, which means 1 centimeter on the map represents 1 kilometer of actual distance. Graphically, a scale bar on the map can show the scale visually. The scale bar allows you to determine distances on the map that correspond to a distance in the real world. So that's something like when they have the little picture on the map where they'd have this and they would say something like that is 1 mile. As a ratio, we can state the ratio of distance on a map to actual distance. For example, there are 100,000 centimeters in a kilometer because there are 100 centimeters in 1 meter and 100 meters in 1 kilometer. So a scale where 1 centimeter represents 1 kilometer can be described as a scale ratio of 1 to 100,000, or 1 over 100,000. Scales have a lot of uses other than maps. Architects and engineers build scale models to visualize their plans. Timelines represents scales of time. A 4-second time-lapse video shows 24 hours of weather. Each second would be 6 hours of real time. A computer simulation of a continental drift may represent 1 billion years of geographical change in just 1 minute. So example 9, the floor plan of your new apartment contains a study, a place for you to do your Math 154 homework. You want to purchase some new furniture for it, and you need to know if it will fit in the room. So let's figure out what the width and the length of the actual study are, given our scale of 1/2 an inch equals 3 feet. And on our drawing, our study is 1.5 inches by 2 inches. So we're going to go back to our favorite concept of proportions. I don't like writing a fraction in a fraction. So instead of 1/2 an inch, I'm going to use 0.5. So my scale is 0.5 inches to 3 feet. I want to figure out, let's start with the 1.5 inches. 1.5 inches is going to go on top because it needs to go next to the one that's inches. Those have got to match when I'm using a proportion. When there is an equal sign in the middle, those same units should be on the top and on the bottom. I'm looking to figure out how many actual feet 1.5 inches is. So now I'm going to cross multiply. 3 times 1.5 gives me 4.5 equals 0.5 times x. I'm going to divide by 0.5, which is the same as multiplying by 2. So x is 9 feet. So I've now found the, I don't know, either length or width, whichever one you want to call it, and I need to find the other one. So I'm going to set up almost the same proportion. I'm still going to use the same scale. My scale has not changed. But instead of 1.5 inches, I'm going to put 2 inches up here. And I'm going to have x feet. I'm going to cross multiply. So 2 times 3 is 6. Equals 0.5 times x. Divide by 0.5, which again is the same as multiplying by 2. And I get that x is 12 feet. So my actual study is 9 feet by 12 feet, which will help me when I'm looking at purchasing furniture.